Welcome to my video on logarithms and logarithmic functions, part 1. In this video we are going to focus on the basics about logs. What are they used for, and what is the setup for them so that we can hopefully put them to good use in making our mathematical lives easier. So let's jump right in and talk about what is a log. Let's say you have this problem in front of you. 4 raised to the x power equals 16. If you know your powers, then you'll know that x equals 2, because 4 to the second power is 16. Okay, but what if it wasn't 16 that it equaled, but 4 raised to some power equaled 12? This is where logarithms comes in, because as we hopefully know, 4 to the first power is 4, 4 to the second power is 16, and it must be somewhere between 1 and 2 for x. That's going to give us 12. And the only way we can figure that out is by using logarithms. So they help us discover exponents for bases that change them into numbers that are different from what we would expect, such as our perfect squares or our perfect cubes. So if I wanted to get 4 raised to the x power to equal 12, I would use a logarithm. And we'll talk about how to do that in a little bit. But now that we know the purpose of a logarithm, let's talk about what it looks like. This is my general setup for a log. You start with the word log. You have a B down here, which stands for base. You have an E here, which is... This is my general setup for a logarithm. You have the word log, which tells us that we're using the logarithmic function. The B stands for base. The A is your answer, and E is your exponent. And we relate this to exponents because in an exponent you have your base. You are raising it to some power with your exponent, and that gives you your answer. So these two are related to each other. The B for the base here is this base right there. The A for the answer is this answer right here. And the E for the exponent is the exponent right there. So let's practice changing a couple from exponential form into logarithmic form and vice versa. Here I have the log of base 5 of 25 equaling 2. Now remember, based on what we just said, this is your base, this is your answer, and this is your exponent. So if I wanted to change this into exponential form instead of logarithmic form, I would take my base, which is 5, I would raise it to the exponent, which is 2, and that equals your answer, which is 25. And that makes sense. 5 to the second power is 25. Okay, let's try a different one. Let's say this time we have the log base 3 of 27 equaling 3. Remember, this is your base, this is your answer, this is your exponent. So if we change it into exponential form, we would say 3 for the base to the power of 3 equals 27, which it does. 3 times 3 is 9, 9 times 3 is 27. Alright, so these may look intimidating, but once you get the format of them down, they're really not bad. Let's try another one. Okay, let's say I have the log of base 25 of 625 equaling 2. Take a moment. What do you think this is going to look like in exponential form? Hopefully, you've said 25 raised to the second power equals 625, which it does. 25 squared is 625. All right, now let's go in reverse. This time we've got to start with exponential forms and we want to change it into logarithmic forms. And it's basically the opposite. So let's take a look at those. Here I have 4 being raised to the third power, and that equals 64. Now if we remember our general formula for the logs, it's the log of base b of the answer equals the exponent. Well, if we need to, let's label our first example. 4 is your base, 3 is your exponent, 64 is your answer. So if I'm going to change this into logarithmic form, I've got the log of base 4 of 64 equals 3. So we took our base and put it underneath the log. We took our answer, put it next to the log, and then that equals our exponent. Alright, let's try another. Here we have 7 raised to the third power equaling 343. And if we put this into logarithmic form, we'll have the log of base 7 of 343 equaling our exponent, which is 3. So there we go. There's changing exponential form into logarithmic form, and we've also done the logarithmic form into exponential form. But what if they ask us to evaluate some of these? Alright, let's take a look. If we're asked to evaluate the log of base 8 of 64, well, remember, this means 8 raised to some unknown power has to equal 64. And since you're not 100% used to seeing it in this form, if you're asked to evaluate them for right now and you don't use a calculator, I recommend putting it into exponential form, because I think this makes a lot more sense. What power do we have to raise 8 to get 64? Well, the answer is 2. So our answer is 2. We've just evaluated that log. Now, what if they give us a fraction for our answer? Such as, what if I have log base 3 of 1 over 81? How am I going to get that fraction? Well, it is important to remember that if you have a fraction with exponents, that means your exponent was negative. So still, I would rewrite this as 3 to the what power equals 1 over 81. And anytime you have a fraction, your exponent is going to be negative. And it's negative because you have the number that you want in the denominator. So what I would do is first solve this problem. 3 to the x equals 81. What power do we have to raise 3 to get 81? Well, I know 3 times 3 is 9. If I multiply by another 3, 3 times 3 times 3, that's going to be 27. And if I do one more, 3 times 3 times 3 times 3, that's going to give me 81, which I want. So, if I have 3 to the x equaling 81, for this, x must be 4. And since I have 1 over 81 here, this must mean x equals negative 4. Because you still get 81, but if it's a fraction, you've got a negative. Alright. That's going to be it for this video. Stay tuned for part 2, where we learn more in depth about how to handle logarithms when we don't have nice squares or cubes to work with, when we have a random number that we got to get a decimal exponent for. Hope this helps, and good luck.